I welcome all of you for today's session. That is the last session in online program of Atal FDP on electric vehicles. So for today's session, as usual, we have first session up to 8, then 8 to 8:15. As usual, we have break that depends upon the speaker and the flow of content. After that, we have 40 to 45 minutes session. Then we have around 30 minutes of online interaction. So with this, today's speaker, Mr. Pradeep Chandrasekaran, Associate Director, Deputy Chief Engineer, OLA Electric Pvt. Limited. Mr. Pradeep Chandrasekaran completed his BE Mechanical and Automobile Engineering specialization in the year 1999 in Government College of Engineering, Salem. And he completed his master's in automobile mechanics technology in Anna University in the year 2001. Then he completed his master of management science operation in the specialization of business administration and management in 2006. Mr. Pradeep has totally 21 years of industry experience in various industries like HR tractors. Then he is a product manager in JCP India Limited. Then he worked in Tata Motors, and he is a deputy general manager in vehicle integration lead in Mahindra and Mahindra, and Force Motors he worked for years. Then finally now currently he is associated with Ola Electric Pvt. Limited from 2020 onwards. He won many honors and awards like Best Champion Award issued by SAE India, and Best Champion Award honored for the outstanding efforts in contribution towards student knowledge sharing and working, and Champion of the Student Convention at SRM. That is the honor he received. We are fortunate to have such an eminent personality with us today, and he is going to deliver the scope of this electric vehicle and its challenges. So this topic is going to deliver the lecture. So on behalf of my own, on behalf of the participants and our Vivekananda College of Engineering for Women and my own behalf, I welcome Mr. Pradeep Chandrasekaran for today's session. So with this, I hand over the session to Mr. Pradeep Chandrasekaran. Sir, please.
Okay. Thank you, sir. Am I audible?
Yes, sir. Yes, sir. Audible, sir. Clear. Your voice is clear. Please go ahead, sir.
So, good evening, all of you. First of all, I would like to thank the management of Vivekananda College of Engineering for Women, and my personal thanks to Dr. P. Kannan and Dr. Kumar, who had approached me to deliver a session in this FTP program and share our knowledge. As Dr. Kannan sir had made a brief introduction about myself, I started my career with the tractor industry, and I was there into the product development at Eicher Tractors, Faridabad. Now that organization has been taken over by TAFE Chennai. So it's no more Eicher. It's like Tractor, Motors and Equipments Limited. Within that, Eicher is a part of the group. So after that, I moved to JCB, where I had been a smaller stint with one of the handling equipment, which JCB was trying to import for one of the orders of tender from Indian Army. But that was a brief stint. Then when I went to Tata Motors in 2004 to 2007, I think most of you might have been a part or might understand the terminology when we say Bharat stage emissions. So recently in April 2020, we all migrated to Bharat stage 6 with respect to whatever engine we have been doing. So that time when it was there, it was Bharat stage 2, what the government of India had mandated by 2004. So we were very instrumental in doing all the products migrating, or I would say upgrading to Bharat stage 2 norms. And I was taking care of heavy tractor trailer. That is, you might have seen on the roads, the tractor which pulls the containers. That is the big containers which keep transporting the material from the shipyard to the warehouse, and warehouse to the origin of production, and etc. etc. Then I had a stint with Mahindra, which was placed to learn, and I was fortunate to have delivered and led 3 projects from scratch. So we call it as in new product development, we call it as M6 program, which is from scratch. That means you don't have any product and you have a complete product. So a typical product life cycle, whether it is in Toyota, whether it is in Mahindra, Tata, General Motors, Ford, it normally varies from 36 to 42 months. That's what the normal period. Earlier it used to be 48. Then people had worked even during that time. We had brought it to 38 or 40 months. Now people are talking about 24 to 36 months. So this is why I'm telling. And then in my last company, Force Motors, we were into the bus segment where we have again delivered this BS6. And from there, the real journey of electrification started. As you all might have seen, when the ambulances are on the road, when you hear the sirens of ambulance, then I don't know how many people also think that there is a vehicle of Force Motors which is coming towards you. Yes, we say that 90% of the ambulances, again, ambulance have different categories. So till 2 or 3 years back, when you hear an ambulance vehicle coming, it was 90% that it will be of Force Motors. Previously, it was part of Bajaj. And last 2 or I would say 2.5 years, the market share has started slowly splitting between Force Motors and the other OEMs. So now it's like 60-40 or 70-30 and etc. And after that, I have shifted to OLA Electric for their car program, which I joined with them in last August 2021. So why I am telling this change, you must be wondering, already Dr. Kannan has given an introduction why he is repeating. The point I'm trying to tell you is, when we move around the industry, there have been changes with respect to the technology, right? That's what I was first indicating. When we did 2004 to 2007, it was BS2. And in 2020, it was BS6. And when we say 2020, BS6, it is at par with the European regulation. 10 years down the line, or I would say 15 years down the line, you could not have imagined that one day Indian regulation or Indian vehicles will be at par with a European vehicle. So the message I'm trying to give is, number one, be ready for the change and embrace the change, right? So as we moved on, it was BS1, BS2, then BS4, BS5 was skipped, then it was BS6. And now after BS6, what? So people are looking now EV as a solution, right? Because there is a limit. I would say, when I say a limit, there is no technical limitation, but limitation in terms of affordability, value addition. See, you can keep on controlling the emissions. Yes, all organizations are putting effort. In fact, people are working on BS7 emissions, I would say. And even in that itself, BS7 and BS6, we have one more interim called BS6 real-time emissions. So what we say as real-time emissions, till we are into the 2020, whatever the emission we were doing, the agency or that will be a standalone. For instance, the agency will come, pick up a vehicle, they will go and test the vehicle, of course, as per the prescribed test and as an independent agency. There won't be any influence. But there will be variation when you drive the vehicle on the road and with respect to the controlled condition testing. So this was already a debated topic at the global level, where the global agencies moved towards real time. That's what, if you would have heard definitely in your courses and related conferences, interactions, they call it as WLTP, real time load profile. So this is what they call it as WLTP. So the interim, which I told, will be measuring the emissions with respect to the real-time road load data. And BS7 will be next. So what is the limitation? I would not say it is a limitation. How we are going to drive the message that still customer will have a value. When we did the BS6, right? Then people were lot of debates were happening, not in the customer area, but in the industry. Because when we are making the vehicles, there is a very, very important factor called cost. You can do n number of innovations, you can do n number of inventions, but ultimately you will have to sell that, whether it adds value. So when we did the BS6 itself, that was calling for huge technical and developmental consistency things on the parts fitted on the vehicle. So ultimately, there will be a delta cost impact, which will have to be passed on to the customer. So if you see, maybe the people, if you interact with the people who might have purchased the vehicle from 1st of April 2020, and prior to that, the vehicles which were in the market, if you would have understood from the people who have bought, they would have definitely bought it at a value of on an average of say 75,000 to 1 lakh or 1.25 or 1.5 lakh, depending on the vehicle, in case of a diesel. And in case of a gasoline or a petrol, it might have been a 75,000 delta or something. So there is a limit to which you can pass on that impact to the customer. So this is number one. So number two is the technological impact. So these are some of the things which are making us to rethink, are we on the right track or should we have some disruption? So when I say disruption, it goes to something which we are not used to, but it creates agility in the system. That means we have been working towards something till date, suddenly some new technology comes and you are getting driven. So with this small brief, I'm going to take you people through the session on electric vehicles, demand and challenges. Believe me, you are all highly talented academicians, lot of coming with experience. So I have kept my note and the tone of the session in a very interactive manner. So it will be like sharing lot of information and knowledge, because at the end of the day, the more you keep the things lighter and the more it will be getting directly imported into your system. Sir, my screen is visible.
Yes, sir. Visible, sir.
Just a minute.
Okay.
I'm trying to go back to the start. Okay. So
Yes,
you are,
sir. Okay.
yeah,
Clear.
thank you. Yeah. So you are seeing a guy who is coolly checking his mail or message, and in the meanwhile, the vehicle is getting charged. So in all ways or all scenarios, electric vehicle has become a very competitive to the existing technology. And already in the developed countries, when I say developed countries, nothing great. It's, I would say, European Union, United States of America, then I would say China, Australia, Japan. These countries have already adapted the EVs to an extent that they have already around 10 to 30% of their fleet. When I say fleet, it's including the personal segment, replaced by EVs. And one more thing, today being the last session of the FDP online, but I thought one more important happening was there in the history. So I thought of starting my presentation with that. Yes, this was on the same day, 119 years before, on December 17, 1903, the Wright brothers flew the first successful flight. It was there in the air for 12 seconds, but that first flight revolutionized the whole world. So I'm sure today this session will also give you definitely a mind-blowing trigger, which will be helpful throughout your career. So like we do for all the other happenings, we say, even if I'm not wrong, yesterday or day before yesterday was World International Tea Day. And somebody calling us Brothers Day, Father's Day, Mother's Day, Women's Day, and etc. etc. But seeing the mobility penetration of EV, the professional community, or the, I would say, the total community around the world who are driving the change, felt that there should be a need to appreciate and congratulate the electrification of mobility efforts. What are the things that have been done that has to be showcased to the world. So it was decided from 2020, September 9th, that every year 9th September will be observed as World EV Day. So henceforth, you also keep it in your mind. Every year 9th September is commemorated as World EV Day. Every country, every institution, every industry celebrates this by, I would say, exposing, by sharing their knowledge, by sharing their developments that they have taken in their e-mobility, and what are the achievements they have done. So, with all due respect, then we can see how we are, I would say, catching up with this technology in India. So this, I would say, horizontal bar chart, if you see, first of all, you see these figures that in October 2022, in total, India had sold 1,16,994 electric vehicles. And in November, India has sold around 1,20,660. In that, if you see the bifurcation, which is the top, that is electric two-wheeler consists of around 76,500 roughly. Then comes your three-wheeler, which is coming out around 35,000 plus. Then your cargo 3,000. And next is very important, that electric four-wheeler, that is nothing but your cars and SUVs. We have sold around 5,370, and last is the buses. So before 5 years, nobody would have wondered that maybe apart from two-wheeler, we will have vehicles on road, which will be affordable to the customer, and customer will go for it. Now you see the case that on an average, we are selling around 1,20,000. So 1,20,000 per month multiplied by 12. So we are going for nearly 14 lakh vehicles per year. So this is a mammoth achievement, but still we have a long way to go, because our total vehicle population is far, far higher, and this is forming a very small portion of the total vehicle population. This is a cumulative chart. So after the last 1 year run, if you see the leftmost first one is the November 2021 sales. If you see in November 2021, we have sold around 42,108 vehicles, and this has kept on increasing. The top graph is nothing but the two-wheeler. So if you see the two-wheeler, it is not a very steep one, but a gradual. There was a spike in March and April, but again it settled down in May to August. And the next one is the three-wheeler. But if you see the buses and the in this, the last one is the four-wheeler. So four-wheeler has been a steady increase from November 21 to 22. So the overall message I'm trying to say here is, it has roughly 3 folds it has increased only between year on to year. And pundits are saying that it's going to be a similar pattern or more than in the years to come. So this chart gives you an idea who is the market leader and who is the player who is consistently maintaining growth in the car segment. So if you see Tata Motors, they have sold around 4,450 vehicles as against 4,270 vehicles in October. And their market share in this month has been at 82%. And next is followed by MG Motors, which has 630 as against 460. Then Kia, Hyundai, BYD, Mercedes-Benz, BMW, and Audi. And in the months to come, I'm sure this list will be more expanded, because people like Mahindra and Mahindra and other players are also going to come. So the point here is, everybody is having a traction observed in the Indian market, and we will be having more and more different type of vehicles that are going to be arriving into the Indian market. And the one good thing is, most of these players are making this vehicle in India. That is the underlining statement. It's not that they are importing. For example, Mercedes-Benz, they are manufacturing their EQS vehicle in India, and this was inaugurated by our Shri Gadkari ji, who is the Minister for Transport and Highways in Pune Chakan plant. And others, you need not be told, all people have their own plans. So the good thing is, by virtue of this models getting launched in India and manufactured in India, India is getting more, I would say, opportunity in terms of technology leverage, and there is a good scope of, I would say, job opportunities getting created. And this is on the bus segment. So if you see here, Electra, Switch Mobility is in Chennai, Electra is in Hyderabad. Then you have PMI again in Pune, JBM in Delhi, Mitra Mobility, then VE Commercials in Pithampur, that is Indore, Ashok Leyland in Chennai, Tata Motors Pune. So in bus segment, it is a level playing game that three players are almost having very near to market share. And electric bus segment is such a segment where you will have a lot of competition, because the investment is huge. It goes for tender, and since the specification are already out, so it's your performance, it's your costing. When I say costing, it's going to be your operation cost and how you are positioning your product. These three are going to be the biggest decision-making factors. Okay, so what are the top 5 reasons to buy an electric scooter in India? One is cheaper to operate and maintain, better for the environment, smooth and fun driving experience, smart safety and technology features. So let's see what is the total cost of ownership. I got an article from one of the editorial. Yeah. So let's go through. This is one of the articles I could see, which was giving the some information about thing. Ignore the things which are diverting your attention on the right hand side, but please focus on the left hand side. So what is the total cost of ownership? The difference. So what is the total cost of ownership? The total cost of ownership includes vehicle purchase cost, running cost, then you have fuel, insurance, other maintenance and service cost. So we call it in nutshell as TCO. So we have taken here, as per this article, a study between Tata Nexon petrol and the equivalent E variant of that. So if you see, this is not a very old data. This is maybe 3-4 months back. So, and this variant still exists. So if you see the petrol version, its ex-showroom price is 9,27,000. RTO charges are around 1,07,000. Insurance cost is 49. Then other some miscellaneous transactions 2,000. Everything put together, it comes to 10.85 lakh. Just note this figure. Now, apart from this, what are the costs that is getting incurred? You have a typical service cost of around 9,000. This I presume that you have it, say first 10,000, then next to 10,000, then next to 20,000. So mostly it should be within this. It may not be beyond this, because nowadays the car systems are much matured and more validated that you don't get early failures. So if you take 9,000, then you take 16 kilometer per liter for 10,000 kilometer, which is a very reasonable. And as per the approximation, if you use with 16 kilometer per liter, you will be consuming 625 liters of fuel. And assume that you go near to 100 liters, sorry, 100 rupees per liter. So for you, the total cost for 1 year is around 61,000. So this all put together, 61,000 and that put together, it will come to around 11.55. Now add on to that more or less the same trend for next 4 years. That is, we have to find out for the first 5 years. So all the 3 years, all this cost will keep coming. Fuel cost will be there. Of course, during the usage thing, you will have a deterioration in the mileage. So your cost of fuel will keep going. Cost of insurance will keep coming down, and service cost will go up. So with all these things put together, rationalized, we come across with adding all these things together around 4.5 lakhs getting added. So it comes to around 16.12 lakh. Okay. And in between, there is a reduction in the value of the asset over the period of time. And this is the total value. Maybe after 5 years, you will have a value of the car at 4.63 lakh. And by this time, you might have spent around 16.12 lakh. Now you see the figures of EV. So when we see the figures of EV, you see first itself, you see the variation in the RTO tax. RTO tax is very minimal. And again, in some states, it has been completely kept null. now only GST of 5% is there, and this is applicable if the vehicle is manufactured in India. It's not applicable for an imported EV. So 13.29 lakh plus 5% GST, around 14 lakh, plus all this RTO minimal amount. Then insurance, again the same. You will not have any registration fee. It is already waived by Government of India and all state government. It comes to around 14.97. Earlier, you had count around 16.12 after 5 years. Now it is coming 14.97. Fine. Now what we can see, what is the charging cost. So the battery capacity of Nexon is 32 kilowatt hour. So if you assume say 12 rupees per kilowatt hour, maybe this is also getting reduced. In some places, I understand it is 8 to 10 rupees and all. So with a worst case scenario or a very realistic scenario, if you put 33 by 12, so in a week, the assumption is for a normal user, because if the vehicle is giving say 200 kilometers or 225 or 250 kilometers, even if you assume on an average you travel 30 kilometers, considering all, you are traveling from your home to office and back from office to home and some miscellaneous travel. So still you are having a decent of say 225 to 250 kilometers as usage. So in a week, you will charge the vehicle only once, because that vehicle, you might have seen in their leaflet and other things, they are talking about say 200, 300 kilometer per charge, but on the actual road, it will vary, because every driver will have his own driving pattern plus the traffic conditions. So this suits more or less. So per week, your expense will be roughly 400. So in a 5-year period, you will have 52 weeks into 5, that is 260 weeks. In 260 into roughly 400, you get around 1,03,000 or 1,10,000. So you add this 1 lakh and say 14.97, it still come to 16.1. Now there will be some definitely maintenance and service cost of the vehicle, which you add everything will come around 3 lakh. So in the 3 lakh, so finally you will end up in having this value around 19.05 lakh as against 16.12. But and not only this, here you see the advantage. Normally the lithium battery on an average is given for 1500 cycles. So every charge and discharge is counted as one cycle. So if you do per year once every week, so there will be, or you also go for twice a week, still you will have per year around 104 charge cycles. So 1500 divided by 104, you will still have around 15 years. So literally your battery life will come minimum from 8 to 12 years or 8 to 10 years. So you need not replace the battery or anything in between. So finally, the conclusion here is it depends. And not only that, you see the rate of the vehicle at after the 5 years, if you see the value of the vehicle is 6.99. So the conclusion or summary here is your initial cost is higher, but your operational cost is lower. Why I'm telling operational cost? This I'm telling per charge. Again, if you are driving on highway or a better road profile or in a different timings, and if you get a better, I would say, more mileage in the sense in the number of kilometers run, then this economy will completely shift towards the EV. And not only this, it depends on state to state electricity rate. So here we have considered 12 kilowatt per hour. If the governments are giving you at a subsidized, and one more thing, in many of the companies now, this I'm talking about the car. Even in the car, you can go for charging at home. So just imagine you come from office, complete your dinner, just put it in plug-in, go to sleep, wake up in the morning, your car is charged. And it is at the same rate as of your home charge consumption. So by all means, the electric vehicle is going to give you a balanced or a very competitive total cost of ownership. Now to move on. So, okay, we are telling that, yes, we have a, what to say, competitive TCO, but then why people are still having a small self-doubt? And I read in a newspaper a few days back, nowadays people's mentality is how, it's like when they are going for buying a car, they are definitely giving a thought, why don't I buy the EV? They don't buy the EV, that is a different thing. But I mean, they are giving a thought, why we cannot go for why we should not go for a EV. So such is the penetration, awareness, public branding of the electrification that people are now thinking twice. This is the shift in the four-wheeler. But if you see in the two-wheeler, many urban segment players are already into the electric two-wheeler. In cities like Chennai, Bangalore, Hyderabad, Pune, Mumbai, you already have many people possessing their own electric two-wheelers. So that shows the confidence people are having in the product. However, to reach to the still further mass, what are the barriers? So these top three are the barriers which are making people think twice or thrice, or making them to postpone their decision for a purchase of EV. Number one is driving range. 35% of the people still feel driving range is a concern if I buy a EV. Number two is the cost. Cost I already explained that how is the cost of ownership, but people on the ground level are still vary because of consistency. Because one customer may tell that I'm getting a better mileage, there is no need of any overhauling, there is no need of any replacement and etc. But the other customer may say that no, I'm getting a low mileage and I have this issues. So customers are vary only from the consistency. The third is charging infrastructure. Yes, the third one I would say was talk 5 years back, but today if you go and tell this, people will either laugh or people will think that you are unaware of the developments. Why? You go to any motels on the way in a highway, whether you take, I have been frequent traveling from say Bangalore to Chennai or Bangalore to Pune or Bangalore to Madurai, right? So in all this, if you see in big motels, big hotel destination points, there are charging points already put up. So you just go. This is replicating the models which are used in European countries. When I have been in Germany a couple of years back, I would like to share my experience here. That I was traveling with my local person who was taking me to the supplier visit and everything in my previous company. So when we were going, his vehicle was having 50% SOC. So he told Pradeep, we will drive from here. There is 100 kilometers. There is a motel, and we'll have a break. We'll collect some food packets and go. So we went there. You'll not believe. He put the vehicle, and in each of the parking lot, you had a charger, and that was a fast charger. So we put it, we went, had a bio break, then we collected some packets, we had a cup of tea. When we came, the SOC was showing 80%. So that's the technology which European and other countries are operating. Now this has also been put up in India, right? Even in very matured motels, we have this charging point. And now, couple of days I read in paper in Bangalore edition, the government agency like Karnataka State Transport Corporation, KSRTC, they are going to run electric buses officially between Pune to Bangalore, might be Pune to, Bangalore to Pune and Bangalore to Mumbai. So with the confidence or condition that there are already established charging points every 100 kilometers. So And as per government's vision is to have every 60 or 50 kilometer, there has to be a charging station. So these are all developments which are happening, which will take the people to the purchase point. But at this moment, these are the defining, I would say not the concern, but thinking points which people have in their mind before taking a call. Others I will not go, because others are more on case-to-case basis. They are not a very well directly proven cases. Okay, the next challenge would be what? We all talked about cost. Okay, so let us break down the cost. So if you see the contribution of the cost, so as per this study, the maximum cost is burned by battery cells. That is coming to around 24%. Okay, who is the next contributor? Next contributor is chassis and body. That is a for body. Then you have BMS and TMS. BMS is battery management system, and the other is the motor management system. Then and the thermal management system. Sorry. Then the next is motor, and then power electronics, and then all others. So if you sum up 20, 31, around 60% is coming only because of battery, motor, and electronics, and rest body and chassis is only 20 to 25%. Last part of the vehicle, sheet metal and others, will contribute around 10%. So what is the plan of the government's vision? So if you see currently, this of course was 2019 or 2020, but still more or less holds good. If you see the current level of localization for chassis and body is huge. We have been doing vehicle with lot of alternate materials, lightweight materials, plastics, then wood, whatever you say. But the level of localization with respect to battery is very low, motor very low, power electronics very low, others are low, BMS are low. Now what is the plan? The government has made a vision by 2025. We should have at least minimum, or we should target for 40% localization of battery cells, 100% of chassis and body, battery management system 90%, motor 80%, power electronics 95%, and others 90%. Even this is a very optimistic, but the pessimistic goal is at least it is on the next 10% in battery cells, 90%, 60%, etc. So at the end of the day, we all form an ecosystem where we try to see how we can leverage this whole in bringing this challenge into an opportunity. So next thing is, we are all talking about some positive things, and we say that there is a scope and others. Yes, but then we have to see also the other things happening around. I'm sure many of you might have seen and talked about what is happening around. Suddenly, there was fire in the dealership. Suddenly, vehicle was there charging. It was getting fired. Suddenly, that vehicle was standing in only the open sun. It was getting fired. Suddenly, there was a car standing in a parking lot getting fired. So there was a huge negative narrative started going around, saying that EV will not be a reality. EV is just what to say, created a hangama, and EV government is pushing, government is doing this, that, etc. So government also plunged into this, and the government ordered a probe into all these fire instances with the DRDO, which was interested into this probe. So the DRDO also liaised with different agencies, and they all came out with some common findings, which was taken from one of the websites. So there were key findings. The BMS, which played a very important role, primarily the software part of the vehicle, was found to be deficient without naming which vehicle or which category. This is the common finding. And second thing, there was no proper venting mechanism, which was needed to allow this overheated cell to release the heat, and was absent across most of the vehicles that caught fire. Then poor quality cells, then shortcuts. Of course, there was a different statement, but in the thing that we need to meet the performance requirement and we need to meet the other requirements. So there have been some individual technology things that were done by the respective vehicle manufacturers, which came to light during this analysis. Hello. Okay. So what were the other things the panel was trying to find was there were also a lot of electrical kits from China, which was only integrated without knowing the technology know-how or the technical know-how within that. Many of the players, because if you see in two-wheelers now, since the different mode of operation and things have been built up, a lot of players have come into the market. Of course, we have to appreciate the efforts of all these players in the market, but few of the players having a limited setup for doing all R&D and safety, they try to integrate the thing whatever at the possible level. So this was also attributed to one of the reason. So after analyzing all these things, government also came up with few of the recommendation. So one such recommendation was government established a very clear-cut direction that we will have to go for adherence to AAS 156. I would request you to go through the common portal of ARI standards, where this is there. This standard, if you go into depth, it talks about clearly the requirements to be met if you are installing a energy storage system in ICE vehicle or the any internal combustion engine vehicle. We call it as for the 12-volt system or 24-volt, and in the traction battery we call it as renewable energy storage system. We call it as REES. So they have put all the requirements which are to be adhered or which are to be met. So this has been put into a confirmed regulatory requirement from December 2021, and all the manufacturers have been asked to strictly adhere to this. Number one. Number two, the government's infrastructure on the e-mobility Niti Ayog, they came up with the proposal that they were ready to even have an open source battery management system, which was being developed by Niti Ayog. One of the key players, as per the statements made in the public media, OLA Electric, they agreed that they would be ready to adopt the government's BMS and as when it comes as operational. So government also put lot of, I would say it's not a restriction, lot of compliances which will avoid this safety fires when it comes to the safety issues. Okay, so this was one challenge on the safety side. Now the next challenge, the very widely but less focused one is, can India's EV ecosystem be truly self-reliant without having access to all this, I would say, rare earth metals. So when we easily say this is a lithium base, this is a lithium ion, this is a lithium phosphate, lithium, nickel, cobalt, everything is said easy. But where are we with respect to the self-reliance on this? So there is a very good article, whether India's ecosystem can be a self-reliant. You must be aware that government of India floated a thing called PLC, that is Production Linked Incentive Scheme for ACC, Advanced Chemistry Cell. So the intent is to encourage the manufacturers in India to put up their own setup, and by putting their own setup and they will try to produce X number of kilowatt hour storage capacity. So the government had given to three players, that is Reliance, Ola Electric, and Hyundai Global Motors and Rajesh Exports. In total, they will all install capacity. It's not only a manufacturing. You have to put a lot of effort in terms of putting into the R&D, development, testing, and validation, and then manufacturing. Put together, all will get around 50 kilowatt hour. 50 gigawatt hour manufacturing capacity put together. I understand Ola had been given 10. Reliance have been given 20. Hyundai has been given 10 or so, and Rajesh is pending among them. So as per the estimate made, there will be around 30,000 crore, and it will be at least taking 3 years to build this. So these efforts are on, and really thank to the vision of the government and the complete committee who is given this, and all these players, believe me, are putting all efforts to make this happen. If it is there, then generating this 50 gigawatt hour is a very, very big milestone in the history of India. And the report says when you are putting on a factory and manufacturing from India, the expected cost is around $148 per kilowatt hour. If you see the today's global prices, it may be 200 to 250 US dollar per kilowatt hour. So still by that data also, we are trying to generate at a much competitive rates. But what is the more challenging, I would say, even this article is also saying, is the availability of critical raw materials. So India is having abundancy in few of the materials, like one is graphite, and another is we have graphite and aluminum to a level where it can be used for the cell chemistry manufacturing. But the other precious materials are not available in India, and this status is giving which are all the countries and how much percentage is being available where. So if you see the lithium, so the major availability is in Chile, 44%, China 39%, and Argentina. Cobalt is in DRC, that is the Democratic Republic of Congo, then China 7, Canada 5, bauxite, Australia, China, and Brazil. Then natural graphite, of course, India also has. So if you see, the most of this availability is concentrated around China. Though cobalt China doesn't have, China has invested very huge on the mines of DRC. So they almost, I would say, control most of the mines which are giving this rare earth materials. So this is a very, very important point. India and the strategists should think in that having a self-reliability or self-reliance, India has to balance how it has to gain more expertise in building lithium-ion batteries. So this is one of the key challenges which all will be facing while making this lithium-ion cells and others. If time, anyway, I am sharing this presentation to the coordinators. You can have a look when you browse through this article. It is very interesting, giving a lot of insight into how it is will be taken care and what is the need. So now time is 8:05. As Dr. Kannan told, can we give a break, sir, now?
Yes, sir. Yes,
Yeah.
sir.
So
we can give for 15 minutes break, sir.
Yeah. So we will, So we will again converge at 8:20.
We will resume back by, yeah, definitely, sir.
Okay.
Participants, please have a break for 15 minutes and resume back by 8:20. Pradeep, sir.
Yeah, I'm audible. Hello.
Yeah, audible, sir.
Okay, we will start.
Yes. Sir, yes, sir, you are audible, sir. Yes, sir.
Okay. Okay. So we saw what were the challenges and how to manage. Now, few of the things we also discussed in continuation. So one, we saw that government enforcing AS 156 standard adherence, whereby all testing has been captured. And one more thing is, like I mentioned about PLI scheme, when PLI scheme is coming into existence, and how the production will be monitored has been also laid down by the Ministry of Heavy Industries. So this is one of the memorandum which they have circulated. So if you see that they have mentioned few of the tests. Please see into serial number 2. So whatever this production packs, so it is reiterated that these tests enhance human safety by ensuring quality at the 3 levels, that is battery pack, management system, and cell level. So these has to be tested as per the laid out requirements, which is there as compulsory from 1st of April 2023. So what are those tests? So if you see, these are the guidelines. For first, they are talking about the cell level. So in the cell level, you will have to have adherence as per UL 1642. That is the impact test, temperature cycling, shock, vibration, fire exposure, altitude simulation. These are all available in public domain also. Then you will have a MOS temperature check, then charge MOS check, then discharge MOS check, and power rail check, then fuse current check, cell balance function check, etc. These are basically done to validate the BMS. Then you have the battery pack level, where you have the case stress, then drop or free fall, immersion, crush, imbalance charging, etc. So this UL is one more certifying agency where it has laid down all the safety standards for the battery. So this is what what is it, like ARI or the European crash requirement. This UL lays down the requirements for the lithium ion battery pack to different type of applications. So as per the application, the codification also differs. So if it is UL 2271, that is for a different vehicle, light automotive or a transport related application. And for forklift, it is a different application. So by enforcing these two, with this international adherence and compulsory compliance, government has made it more strict that it has to be met by the all the manufacturers, and failing which their product or the approval will be pulled out. Now, these are some of the things which are being enforced, or I would say where the government pushes the manufacturer to give the complaints. But there are something which also on the infrastructure side being getting improved. So one such is, this is a news link I have taken, the statement made by our Ministry of Road Transport and Highways, Mr. Nitin Gadkari. So he is telling 2-3 information in this. So first information I am just reading out. When he talks about electric mobility, so he is addressing the thing that by 2030, electric mobility will be the most effective, number one. and he is mentioning about a delegate from Canada, where this delegate has demonstrated how we can get a cobalt and manganese from mining in the ocean waters. So this is very interesting, and if it is done, because India has a huge resource for the I would say water resource. So we have lot of I would say minerals unexplored. So this is one technology whereby we can have an extraction of cobalt and manganese through mining in the ocean waters. This is number one. Number two, one more interesting, if you see his comment, he is saying currently our logistic cost is the biggest problem, right? If you see currently the logistic cost comes to around 16%, and he is telling by end of 2024 we will make it to single digit, maybe up to 9%. That means this, if it is coming and effectively implemented, maybe this can be done in a way of handling this in a very effectively. This type of measures, if taken, fuel efficiency improvement, conversion to electric, these are all going to reduce your logistic cost. So this is a very important information he has shared. And other than that, he is stressing on the need that Indian road condition should improve, because you are seeing even during the daily traffic condition, how much time we are spending idle in the traffic, not only idle in the traffic signal, but even during the traffic congestion, how much excess fuel is spent idle, or the how much time the vehicle is standing waiting for the clearance from others or something. So three things: trying to explore mining from the ocean waters, number one; improving the road infrastructure, which will also aid to electrification, and also this will reduce in the logistics cost. And third is how to push e-mobility to the fast track. This is the three envisionary statements made by the minister. Yeah. So what is the other projection saying? So one of the reports which I have read in Money Control, it's talking about that India's electric vehicles value chain revenue pool will touch 76 to 100 billion by 2030. So what they are trying to tell is the four-wheeler passenger segment is expected to fall behind the adoption curve. The segment is still accounting for 15 to 20% of the four-wheeler PV sales. That means by 2030, end of this decade, okay, then it is, they mean to say around 15 to 20% of the cars will get converted into a EV. And this institution is projecting that 40 to 50% of the revenue pool will come from the auto OEM, and it will be having a major impact in the composition. And there will be new business opportunities which will be getting created. For example, from the battery, because battery manufacturing or cell manufacturing cannot go on its own. There will be a lot of ancillary support required. So emerging will be battery opportunities in battery. Then you will have opportunities in the charging segment, and then the mobility as a business itself will grow. So if you see that all these three is going to give additional job opportunities and business opportunities, thereby the revenue pool will be increasing. So, and as I started with the note that we are already selling nearly 1.2 lakh vehicles on an average per month in a year. So the projection is also that there will be a 35 to 40% of all vehicles sold in India will be EVs. So today you have just 2% of the total volumes being sold. So So if you are saying I am making, if you are not wrong, we roughly make some lakhs of vehicles in per month. This is including the two-wheelers, exports, imports, and other things. So if this report goes through to be true, then by 2030, there will be a penetration of 35 to 40% of electrification in the mobility sector. Okay. I don't know whether anybody read this article in the newspaper. I would like to make a stop here. I would like to listen from participants. Anybody had seen this article in paper? Please put it in chat, or you can just show up.
No, sir. Certainly not, sir. No, sir.
Okay. So why I asked you this question is many people had put this thing. Sorry, many people who are not in favor of having electric mobility spearheading had put this as a very big, I would say, propaganda in the public media, saying that, see, Switzerland itself is going for a U-turn, Switzerland is banning EVs, etc., etc. So I was also alarmed when I saw this statement, and when I just saw this article, then I could understand the reality. The reality is, if you see, you all know that Russian invasion of Ukraine. So most of the energy requirement of all the European states, in particular countries like Finland, Switzerland, Denmark, which are more reliant on the other European countries and Russia. So what is happening? While it's not like in India that winters are very, I mean, I would say bearable cold. In what to say, in the countries, Scandinavian countries, and all the Northern Europe countries, the temperatures go very low, that you need to have more energy to fire up. That means if snow falling is there, then you need to have lot of heaters in the house, then heaters in offices. Then so ultimately there will be lot of natural gas and other things which will be required. So basically, the electric consumption is also created from two sources. One in these countries, one by hydro, and another is from all this gas and other media. So what has happened because of this war situation, the scenario of getting this energy through the pipelines have slowly started decreasing. So that's what this partial ban of EVs came into picture. You see this article, you will understand. They are talking about partial usage. The production slows down in the winter, then further the country gets. And they are also talking about French utility of electricity is also going down. So from this aspect, then just a minute. Yeah, they have also put an ordinance on restrictions and prohibitions on the use of electric energy, which is from the lot of reports they could see. So their council is also adapting a policy to manage or handle this energy shortage. So they have made different type of escalations. So that is at the top level, then number 3, number 2, number 1, and only at the third level of escalation, they have mentioned about the e-mobility effective. So what is that draft says? The draft says the private use of electric cars is only permitted for absolutely necessary journeys. That is exercising one's profession, shopping, visiting doctors, attending religious events, attending court appointments, etc. So the leisurely activities are to be curbed down. So because the ordinance aim to regulate the restrictions and prohibitions on the use of electric energy, it is likely that an overall ban on EVs will be replaced by a partial ban. And whatever I have mentioned, they have also written the same, that they will not go for too much of warmthness. So the buildings will be having only temperature control of up to 20 degree, because during the snow time, it will be going into minus and others. And they will also ask the people to limit the temperature of their washing machines to not more than 40 degrees. So these are some of the things which will be done at the operational level. In Switzerland, also they are decided that the business will be asked to close 2 hours earlier if the situation worsens. So why I am mentioning this? Any guess why I am mentioning this point here? Anybody would like to share their views? Okay. I mentioned this because if a country like Switzerland, which has enormous, I would say, if you happen to tally the available resource versus the utilization, that is, if 100 square meter of forest is there, what is the proportion of number of persons occupying per square meter in that forest? So if you see that calculation and density with respect to India, that will be very, very high in Switzerland or any other developed nation. In India, it will be less. On the contradictory, that in India, the people who are using the electricity is very high. So we always have a deficit. So please try to link this. Imagine today you have only 5,000 or say 5,000 cars per month. So which will translate into 60,000 cars per year. Fine, this is good. But if out of drive for electric mobility and etc., government initiatives, incentives, etc., people start shifting more. And in next 2 years, it becomes double. Say, for example, monthly we go for 10,000 cars. And in the yearly, it will be 12 I would say 1,20,000. Then it keeps going. Now, the problem is one side, it is good to see so many vehicles sold out. It is good for manufacturer. It is good for pollution, fine. But are we having the necessary support for energy? That means what I'm asking, when you are charging the vehicle at home or office, finally from where you are getting? You are getting from the grid. The grid is supplied by electricity from the energy source. Say, for example, it can be a hydro, it can be a thermal, it can be a wind, or it can be a solar. But the last two are normally used for light load applications, not for a very high load. So in case of very high load, it will be more of a thermal or a hydro. So the message here is, when we strongly push for electrification and everything, the government has to focus on how we are going to balance the grid. So that's what I'm sure you will all be teaching all these things called bi-directional charging, where or they call it in different terms. One is they call it as bi-directional charging, and in some other versions they call it as smart charging or smart grid. So what they do in smart grid or smart charging, in one phase of charging, the vehicle pulls the charge from the grid. That means it pulls the charge from the AC and it converts it to the DC, and from there it will be charged to the battery. But now what is happening, after that the charge is there on the vehicle is during the say I go to office, in the office by 10 o'clock, I just park the car in the sun or in the parking lot, and I return from the office only at, say, evening 7 o'clock or 8 o'clock. So till that time, what is happening? The car is standing idle and the car is fully charged. So what is the use of it? It is just having a redundant storage of electricity in the vehicle. So instead, what we can do is, during the day, the vehicle can be charged, used for charging the grid. That means the flow can be on the reverse, that it flows from the vehicle to the grid. So that's what we call it as V2G. So this smart grid or the smart charging or the level charging. So this is very well implemented in countries like Netherlands, UK, Germany, US, many parts. In India, this model has been done in one of the areas in Telangana, where they don't exactly do this model, but they do it in a different model. Say, for example, I'm having a car and you are having a car. So what is happening is, when I'm trying to charge, you also try to charge. We both try to pull the maximum load from the grid. So instead, if I come down and say, no, I don't want to charge now, I will charge during the off hours. So one guy charges in the peak hours, the other guy charges in the off hour, and also during the off hour, the guy is ready to give back the energy to the grid. Then he is getting compensated. So this type of models are already being followed in states and union territories, like it is being followed in Delhi, in few of the areas, and also in Telangana, it has been followed. So by this way, the grid is getting balanced. So when we talk about deep penetration of electrification, how we are going to balance the grid, and in this, the mostly recommended is to go for the solar one. So when we go for the solar, we try to put our charging stations which are, I would say, using solar energy, which takes partially the power from the grid, but majority of the power it takes from the solar. So these models are already proven in developed countries. When we expand our network in India for charging, these all to be put in, so that as a buffer in the system, and we don't also get choked up because of this grid crisis. Okay, so we saw all these things, how to manage the grid and everything. Now, on top of all this, definitely when it comes to a alternate solution with respect to EVs, somebody argued that no, EV is the only solution. It has a very big pros and cons and few consequences, but there are options and there are other solutions which I am discussing here. So first is the biomethane. These are areas which people are yet to deep dive, and I mean, a lot of research has been done, but the commercialization is very important. So if you see, in terms of environmental pollution, biomethane has 80% less carbon footprint in comparison to fossil fuels. So that is a very important thing to be noted. And because of this, carbon dioxide emissions are reduced. One more positive thing is biomethane can be provided in the liquid form. So the car can be run anywhere between 400 to 700 kilometers on one full tank. Now, the second major, very, very interesting and very novel thing is the usage of hydrogen. Hydrogen can be, and any guess which is the next to oxygen, which is the highest available, I would say, element in the air? Anybody? You can put in the chat box also if you have any guess. Okay. Next to oxygen, which is available, is hydrogen. Hydrogen is the lightest and the most abundantly available next to oxygen. So you can just imagine how it will be. Like wherever you are going, you are having oxygen, right? That is what you are able to breathe. You just go from here to next place, in between lot of trees. Whether trees are there or not, you have oxygen. That's what you are surveying. Even in the sea, up to a certain level, you have oxygen. Below that, you don't have, though you have to go with cylinders. So such a abundant fuel is hydrogen. But the problem with the hydrogen or challenge with the hydrogen is what? It has become the lightest one. So when I say lightest, for storage within some compartment, the atom being the lightest, and it has a different or the lowest volumetric efficiency, though it has a good specific density. So I have to pack max level of hydrogen to get an X level of energy from the hydrogen. So this is what the limitation we are facing. But however, a lot of research work has been done. Today also I will be taking you through quickly on the few developments on the fuel side. Because as I started, technology-wise roll-up will keep on happening. Now we are in the EV phase, but then what are the limitations in the EV will be overcome in the next technology. Probably that mass scale will be the fuel cell. So to cut short, hydrogen is the next abundant one. And apart from being the lightest, it has a good energy density. So we can go for hydrogen, which is a clean fuel. And one more thing, since there is there is an interaction only between hydrogen and oxygen, the end product will be always water. Water will be the end product. So it is the purest form which it can be done, but it comes with some consequences, especially in terms of cost and space. That's what at all places a fuel cell cannot be applied or thought of. So this is the number 2 technology. Number 3 is hydrous ethanol. This many people should be aware, definitely, because after this Modi government came, they have been step by step increasing the consumption of ethanol in the diesel. That means E100 means what? Completely the engine runs on a ethanol. That is what. But right now, if you see, we are started with E20. That means E20 means it is having 20% of ethanol and remaining 80% of the diesel. And again, here the thing is, while we have proved that ethanol will be a next alternate solution, again, availability is a question. Why? Because today ethanol is being consumed or extracted as a byproduct of the sugarcane molasses distillation and other things. Currently, it is consumed for food industry processing and others. But once you try to use that for the fuel, especially for a big consumer like India and the Indian customers, it will be a huge demand. Are we having that much resource? Question mark. So this is what, this is not further entering into more of the mobility area. However, government is doing in a phase-wise manner. But this technology has been very proven in countries like Brazil and Thailand. In Brazil, Brazil is the number 1 manufacturer in sugar ahead of India. So they have a huge resource of ethanol. So ethanol run vehicles are successful in Brazil, considering the availability and the consumption. Now the next one is the biodiesel. This is taken from vegetable oil, recycled fats, and etc. This has been an area on which work has been going for quite some time. And the last one is, you know better, it's a solar. So out of this, I would say A lot of work has been happened on fuel cell globally. In India, it's taking shape. Lot of activities are happening, and whereas in hydrous ethanol, lot of prove out has been done already, but only considering the availability limitation, the government is taking a very wise call. Okay, so in India, what are the things being talked of when we talk about an EV? So this is a term in Hindi, mileage kitna denge. That means how much mileage we will get it. So when we talk about a customer of Indian market, the first thing he sees car is as an investment. It is not for a comfort, which is being perceived in developed countries. So when we have a customer in India, first he will think, or he will ask that what is the level of utilization or value addition I will get. So he will think, today I'm going with my family. If without car I book a Ola, Uber or whatever maybe, or I go by public transportation, I incur this much cost, this much time, etc. While I'm going for a car, I will be able to save this. So first thing when we talk about an Indian customer is a value addition, number one. So you have to give that. So that's what we again correlate to the mileage, what we spoke some time back. So mileage kitne denge? What is the mileage it is? So people are conscious on the mileage. Second thing is autonomous driving technology. Yes, India is not very ahead in this as a I would say implemented technology, whereas lot of work is happening on the innovations on this. So again, we are all blessed to, we are going to see this evolution also in 5 years down the line. Now, the third thing is, gone are the days where the car was seen as a means of shifting one person or transporting one person to the another place. Now, car has become a place, especially the EV, has become a third space. Why? The point number one is your all moving parts because of the engine has been taken out. So when you say all engine and parts have been taken out, then you have two things coming into picture. One is it has become a very silent vehicle, and so the interior will boost you more comfort when you are on the move. So you can start attending meetings, you can do on the go some discussions, some mail checking, etc. Number one. Number two, from the utilization point of view, the EV gives a front end space because your engine is taken out. The motor is not going to occupy that much space. So when we say the engine is taken out, just imagine for a second engine is taken out, only radiator and condenser will be there in the front, and there will be a motor and the thing which will be along the axis of the wheel. So what is the benefit of that? You are getting a clean space. This we call it in English as frunk, right? Like in the rear, we call it as boot space. In colloquial, we call it as dicky space. But in engineering term, the rear is called as boot and the front is called as hood. In the EV, because of virtue of elimination of IC engine and all the other peripherals, we get a space that is called frunk. So frunk is given and the vehicle becomes more silent and more comfort. So the vehicle itself becomes a third space. And the fourth very important advantage which India has is the cost. For example, the ISRO spaceship launch, for instance, was done in a cost less than a Hollywood movie. So such is the cost, benefit, and the knowledge talent pool which is available in India, which can be leveraged for all these developments. So India has a vast potential to make EVs with higher range at cheaper cost. And the last and the very important thing, I think you had one session also on this. The government is promoting a lot of startups and campaigns like Make in India seems to make a difference. That day I was watching one interview on a channel called WION. They call WION. So in that they were mentioning the moment this government, which is going to complete the second tenure, took office on 2014. The first one of the thing is the Atmanirbhar Bharat. That means make in India, make it self-reliable. So it has yielded really space for in-house, or I would say within the country, the development. And these days, many of the foreign companies are signing contracts to put up their setup in India. And recent one thing, anybody tell? One of the big companies in the world has put up I would say a manufacturing plant in India. Any guess? Anybody want to tell? Okay. It's Apple, right? iPhone 14. So they have now put the plant in India, and now it is going with the label with made in India. So that day I was watching a YouTube channel interview. Pakistanis were comparing the Indian growth, and some interview was happening. Somebody was taking, but during that conversation, they were exchanging their ideas. So that time they were mentioning in Pakistan, ideally all these iPhones and things, they don't have anything on their own. So these are all either brought inside into an illegal manner and sold in the open market. But now they are surprised to see those mobiles with the tag that made in India. So such is the vibrant growth of India, that slowly Indian continent is not seen as just a manufacturing or a cheap market. It is seen as a market of talent pool and a very positive growing environment. And there are a lot of examples we can bring, but I would say a few of the things which are also in the pipeline. Definitely you must have heard about GE and Alstom. They have put when the Indian Railways commercialized the few of the coaches and the locomotives, right? If you see current locomotives, I would say current is 2 to 3 years back, or you can say 4 years or 5 years back. The maximum, what to say, pulling power of a locomotive is used to be 1200 to 1500 kilowatt or something. So you must have observed when you are going there in a train, or in my school days, I used to observe when the gate was put. That time over bridges were not there. So when the trains used to pass, especially the goods train, two engines used to pull the things. These are all inefficient ways, because you have to feed both the locomotive, you have to put all the coal and everything. But now with foreign market leaders like GE, which is the world #1 in locomotive, they sold their business of locomotive to Alstom. Alstom is a French company. So they are now putting up factory, and these two people are making locomotives which are pulling, or which have the capacity of taking 8,000 kilowatt. So just imagine, where was 1,500 and now how much it has gone to 8,000. And they have a factory in Uttar Pradesh and a few of the areas. The point here, or the message here, is the government of India's two important things. One is startup and another is the Make in India, is really giving lot of challenge and disruption in the technology area, which is definitely going to give lot of benefit to the Indian e-mobility also. Now the next thing is, so we were wondering, right, next to EV, what is that? Yes, next to EV, what is that is, we talked about the technology on fuel cell vehicle, and there is also a thing called hybrid. I'm sure you must be aware of this technology of hybrid. Hybrid is nothing but where you reduce the load. I'm explaining in very simple terms. You reduce the load of a IC engine by providing a small motor and a battery. So what these guys do, so normally the engine will not be running in all conditions. The initial kickoff or the initial start will be by a motor. After some time, after it achieves certain speed, it gives the drive to the engine and engine will go. Why is this? Because between engine and motor, in the motor, there will be a quick pickup, right? If you see the power torque curve, the torque is shooting up like immediate exponential. Whereas in case of IC engine, especially the engine, the initial pickup or the lag will be there because there are a lot of moving components inside the engine which cause friction. That has also that all to be overcome before the actual torque is moving the vehicle. So a hybrid reduces the load on the engine by which the engine will be forced to operate only on the high efficiency zone. So in a manner, you will save energy, number one, you will increase the efficiency of the engine. However, this comes with the drawback that the control of the system is very, very complex. So if you see the technology as such, you have here a comparison between different cars. So number one is the Honda Clarity, a 2021 model. Then there is a Toyota Mirai. And by the way, this vehicle, Toyota Mirai, has been launched in India. If you can search, you can see that this vehicle is a hydrogen fuel cell concept vehicle, but which is going under a lot of developmental trials. Then the XLE is a one more variant, and Nexo is also a variant. Now, the interesting figures you see the range. First one is all are mid-size car or a compact car. So the range in miles is 360, 357, 400. Like 400 is higher, but 360, 357, 354, everything is near. Now, the Mirai is a fuel cell vehicle. Clarity is a EV, and the others are hybrids. So if you see to match with respect to the EV, the FCVs have also come very nearby. So if you see miles per kg of the vehicle, or you simply see miles per gallon, so 68 in combination, 68 in city and 67 in highway. And the FCV is not very far behind. It is 65, 67, 64, and again hybrid are there. So the message from this slide is the FCVs is going to be a next level of technology, which are having some upper hand on the EVs because it is an extended application of EV. However, there are limitations on the FCVs, which if overcome, that will be the future technology. So apart from this, just a minute. I want to share a few more info. My slides are not moving. Okay, so I explained about fuel cell. So just to take you on few of the quick snapshots of fuel cell. A fuel cell is what, like in an electric vehicle, you have a battery motor like that. Fuel cell is just a small unit where there is a positive electrode, where there is a negative electrode. Then you have the hydrogen being pumped. As I already told, hydrogen is most abundantly available. So what is the action happening is, once the hydrogen is passed, then the hydrogen is stripped of the ions and the ions pass through the membrane, and whereby the circuit gets closed. This is a very simple way of explaining how a fuel cell works. So one side it is hydrogen, another side it is oxygen. In between you have the membrane and the passing of air. And since you have hydrogen and oxygen getting mixed, then final output will be water. So how the fuel cell is classified? The fuel cell is classified based on the type of electrode and the type of the membrane. So in this, if you see, as I told, one is hydrogen and another is oxygen. Oxygen is oxygen. There is no change in that. We are trying to trap the oxygen because oxygen is everywhere available. It can be stored in cylinder. Whereas if you see the hydrogen, hydrogen can be provided or can be used from different sources. Number one is you have methane. Methane is CH4. So from that we can extract the hydrogen and use it. And number two is it can be used in the water in the form of a solution. Number three is hydrates. Hydrates is nothing but we have chemical substances in which the hydrogen is already impregnated, and this hydrogen can be with the help of either an exothermic or endothermic reaction can be taken out for during the reaction. So this is the way how the fuel cells are classified. In this, very important thing is two extremes. One is the PEM, proton X membrane, in which the electrolyte is a solid polymer membrane, and SOFC, that is solid oxide. So in the solid oxide, the source of anode is, the hydrogen is methane. In PEM, it is actual hydrogen. And the efficiency is highest on the SOFC. All others are in between. So this is again the temperature stability, how each of these fuel cell behaves. Yeah, so like the standards have been established for EVs globally. There have been standards established for fuel cell vehicles also. So all this technology or adherents are already globally available. In India also, we have adopted few of these standards, and we have also made our own standards. We say that what are the standards applicable for fuel cell vehicles or the hydrogen. This is a small comparison and interesting, which gives you what will be the projected cost of different technologies. So if you say a fuel cell system cost per kilowatt will be 70, this is only the generated cost. Of course, the part cost and the other installation cost are different. So cost in that way will be higher. This is per kilowatt cost. And if you see the lithium, that's what I was explaining. So you see by 2020, they are telling about 450 or so. And now we are at 2022, we see that say 200 to 250 or 300 might be the per kilowatt hour. And 2030, it is going to decrease. So the message here is among fuel cell, electric motor and lithium battery, EV is using the lithium battery, but you see the cost competitiveness of fuel cell. Fuel cell, the generated cost is less, while the installed and the other infrastructure plus all the system cost will be very high. And if you see the hydrogen, just imagine how less it is. The engine, the internal combustion cost comes to around $42 per kilowatt. But if you see the hydrogen storage means, so it's having just 12 or 10 kilowatt hour for $10 per kilowatt hour. And with the countries like Australia and Iran and other countries, they are putting a lot of efforts to further bring down this cost down. So these are all viable options, but these are all extensions of the basic e-mobility system. So again, these are some of the schematics, how this circuit works, different fuel cell things. So here the major is how the hydrogen is pumped into that, what is the valve, how it is done, how the air is put, that is a compressed air, then there will be heat exchanger, then how the interaction happens. Yeah, fuel cell market will explode, and they are forecasting by 2026 there will be more than 4 lakh units across the world, and they are also anticipating that this will be exceeding 1.5 gigawatt by 2026. So there is a huge potential. Again, it is an offshoot of the e-mobility and EV technology. So here it talks about what is the cost comparison of the stack and the electrode. So in the like I explained in the EV, the battery is the most costliest part, and which takes away around 24% of the total cost. Here the electrode takes away the maximum cost of the fuel cell, and as a total system, the stack, the fuel cell stack, where the membrane, the electrode unit and everything is stacked, that takes the maximum cost. These also in the fuel cell we have a catalyst to accelerate the thing, that is the platinum. So as you see, there is a small inflection in the consumption because of more and more vehicles being built. And one more interesting thing for you is to note that if you see, the world is split in terms of adapting this technology. Number one is across the globe, European Union, China, US, partially, they are completely into the electrification, or I would say the battery electric vehicle. When you talk about fuel cell vehicle, especially Korea, Japan, then this side, we can say a few of the South American countries, they are investing more into the FCVs. And hybrid, again, the focus is more on the South Asian countries. In case like countries like India, we have started with more of battery vehicles, and because we are finding short of the rare earth metals for the fuel cell, fuel cell vehicles, and also how to store the hydrogen. So these are some of the factors because of which India has not shifted completely to the fuel cell technology. So these are the systems related. I have just here it's talking about the split of what is the cost of each of the system and how much is the capacity and what is that. So if you see, this is a 2018 data as per one of the US websites. So 100 kilowatt system comes to around 1.5 crore, 250 kilowatt comes to 2.5 crore, and each of the bifurcation is given here. This is a typical spec of the fuel cell, how it is being used. And as I was mentioning here, the efficiency of the fuel cell is not equivalent to that of battery. However, it is far, far improved compared with respect to the IC engine. Then you have other specs, how to quantify that. What is the voltage, what is the active area, net power, etc., etc. Yeah, this is what I was mentioning, how the fuel cell works. So you have one battery, because at all conditions, both fuel cell and battery will not work. So the battery will be needed when there will be a sudden acceleration. So when more power is needed, the battery supplements the fuel cell's power output. So this is a one way of hybrid, which will help. This is a system layout, typical how the fuel cell will be. Yeah, this is interesting. So this shows you an idea how it is fitted for a vehicle size. For example, for a two-wheeler, for a car, or a small pickup, which has or which targets say range or mileage of 400 kilometer max or 425. We go for a battery electric vehicle or nothing but the electric vehicle. However, when you get more space and more range is required, then you go for a fuel cell, especially bigger cars, vans, and when you go for big trucks, you automatically get more space for package. So you automatically go for more deployment of FCV in this category. And this is a comparison they have given. So FCV can go up to 60%, whereas battery electric can go up to 90% efficiency. Yeah, this is one of the very interesting. I don't know how many people are aware of this. Even the tiny secretion from the insects like cockroach or anything, or even from all animal, that has small amount of energy, which also functions as a fuel cell. So if you go into this, you will find out very interesting facts that biofuel cells are there, where scientists have done that even from the enzymes secreted by cockroach. That is, one enzyme's name is trehalose, which goes and does some chemical action and split it into trachlase and one more thing. So in a way, it acts as a source for hydrogen, and then the same chemical process. And so this is from the insects. Then already a huge database have been collected on different things. The work has been happening for last 50 years. So experiment has been done on dog, sheep, then rat, cockroach, clams, then lobster, snail. So this chart gives you in each of this how much electricity, what type of voltage is generated. So it's amazing to note that cockroach, it has a 0.5 volt and a 4 microwatt it is getting developed. So in a dog, they have also found implanted a glucose fuel cell and trial this, and with this they were able to generate the energy. Even in the snail they have done this. And then there are e-biofuels fuel cells on this, where it is it's a bio, and it is working in the principle of the normal fuel cell. Then there is an integrated unit, how it works. Then system mechanism. Yeah, here it is the main difference. In SOFC, power is generated from the movement of oxygen ions in an electrolyte solution, whereas in PEM, it is generated from the movement of hydrogen ions in an electrolyte solution. So this is the major difference between these two. So SOFC is having higher efficiency because it is generated from the movement of oxygen ions, and it is more controlled, more stable. Whereas PEM is from the hydrogen ions. So the hydrogen ions controlling the process is slightly more complex and less effective. So there are micro fuel cells. This is one of the fuel cell developed by Simmerai from India and agency. And this has already the spec power ranges from up to 5 watt they are able to get, and energy content is 30 watt hour. Membrane area is 1 to 33 centimeter square. So a lot of research are further happening on this. Then this is a display of that unit, how the solid oxide fuel cell work. Whatever I have briefly explained is given here in the schematic. These are some of the infrastructure which is put in the US grids. This is again a comparison I have made between the different vehicle using different technology. So in each of this, what is the last vehicle is a complete only a EV. So each of this you see what is the acceleration. So in the EV, the max speed is 160 per hour. In the fuel cell vehicle, if you take 0 to 100 kilometer per hour, that is what to say achieved in a very slow very more time. Because if you see 0 to 100 miles per hour, a battery electric vehicle typical may cover in 5 seconds or 6 seconds, whereas a fuel cell covers that in say 9.6 seconds. So there is a lag. So the efficiency wise, fuel cell vehicle will be slightly dragging. These are other, but you see the compact package of the things. If you are going for hydrogen, then it will be a 700 bar normal working pressure. There has to be a tank for storing all these things, and a lot of protection also needs to be given. This we already discussed. This is a fuel cell market they are talking. As I told, it's going to explode in next 10 years. So the next level of electric vehicle is going to be the FCV. These are number of cumulative installed units in different countries. That's what I have mentioned. For all this fuel cell, Korea and Japan are in the lead. Germany is also doing a lot of work on that. So we will have more number of cars and vehicles in these stations. Then this talks about different countries, how they have plans for putting the fuel cells. So if you see, almost countries like Korea is leading, then China is also there, France, Germany, Japan, everybody is putting. So by I would say 2025, California plans to have 200 hydrogen refilling stations. China plans to have 300. Europe minimum 750. Germany 400 and Japan 300. So there are growth factors for FCVs in terms of vehicle by type, range, and region. Again, by range, it is giving more. And as I explained, in terms of vehicle, which category of vehicle suits more for the FCVs. Then these are some of the players who are already working. You have Audi, BMW, Daimler, Honda, Volvo, Toyota, General Motors, Mansei, American Honda, Toshiba, and Ballard. So all these people are working either development on their own, or they are doing a joint venture like Renault and the Plug Power launched a Hyvia joint venture. Tata Motors has also come into JEV with the IOCL, and they have bagged an order for providing some 15 hydrogen buses. So a lot of traction is happening on this area globally. As I told, these are some of the standards. I'm just rushing up. And these are the institution where fuel cell research is happening in India, and in what area they are doing, and what is their achievement. Say, for example, BARC, IIT Madras, IIT Delhi, Bombay, everywhere Tata Motors is doing, IOCL is doing, Reliance is doing. So everybody is working on PEM, then SOFC, then different type of hydrogen storage. So just to summarize, this will be the technology for further future. I would say this we can definitely see by 2030, more of the cars in India. In the next slide, one car is coming. This is the first hydrogen fuel cell electric hybrid car. This was what I was trying to tell you. This is nothing but what to say, our Toyota's vehicle. They have made a Toyota and one more KP80. They have made a vehicle together, and it is in the form of developmental trials. Having said that, fuel cell vehicles have upper hand, not in all areas, but in certain areas where there is a limitation in the electric vehicle. However, the call for implementation, like I in between also mentioned, whether you go for a battery electric or a fuel cell electric, depends on a lot of other factors, how you implement and what is the support in terms of technology you get for making that depends. So with this short note, I would complete my session now. So just to summarize, in the last 2 hours plus, we have seen that how the evolution of EV has happened, what are the potential positiveness in the Indian segment, what are the challenges in the Indian segment, how it can be converted into opportunities by overcoming those barriers. Then after that, I also tried to take you through what are the technologies which are competing with battery electric vehicles, fuel cell, hydrogen, and we also talked about ethanol and others. So out of which fuel cell has more potential because it is trying to integrate the available technology, especially with hydrogen as a potential. So fuel cell will be one of the definitely competitive solution, but of course it depends on a lot of other factors in terms of cost, technology availability, and other things. So this is what I would like to summarize.
Thank you, sir. Thank you very much for your excellent presentation. Before going to that, I am assuring you that 9th September will be celebrated as a EV day in our college, particularly in our department. And you told a lot of things with industrial data, what is available now. So definitely this will be, particularly this case study, what you have given about Tata Nexon. So that was excellent, sir. And you have given holistic development of this EV. if you want to make any analysis, we have to consider positive as well as negative, because most of the lectures I found that the people are taking only positive, but you have taken negative also for analysis. So as an electrical person, without positive, without negative, the supply will not come if it is a DC, right? So you have given a lot of analysis and the developments you have given excellently with the data. And another point I want to insist at this juncture is cost is the major worry of this electric vehicle. But if more people are using, automatically it will be reduced. For example, if you are taking this mobile, so around 96, 97, so they are charging for incoming call as well as this outgoing call. Then afterwards, it is getting reduced. Now everybody is having if you are giving your name, the next thing what they are asking is what is your mobile number. So similarly, the vehicle revolution may takes place.
Yes.
And another another interesting thing I want to tell you at this juncture is, so I am in Chennai for the past 2 days for attending this 37th Indian Engineering Congress organized by Institute of Engineers, Kolkata. So there, one guest told Mr. Ganesh Mani from Ashok Leyland, he's a chief manager operation. He said any technology which was sustainable and eco-friendly, sustainable development and eco-friendly, definitely all should adopt for the same. So this is the thing I want to tell you in future. So we are going to adopt this electric vehicle technology. So thank you very much, sir, for accepting our invitation. At this juncture, I have to thank Kumar, Dr. Kumar also. He only told me my friend is there. Definitely, he will come. He will have a lot of knowledge in this area. So that has been reflected for the past 2 hours. Thank you very much, sir. On behalf of all the participants and my own behalf, I thank a heartfelt thanks to you for sparing your valuable time with us. Thank you, sir.
Yes, sir. Welcome, and thank you, participants, for your patience listening. And I'm sure, like I started with my note, the data is very important, and we have to keep this data for our quick reference. So let's all celebrate, as Dr. Kannan sir was telling, every year this EV day. So every year we keep moving with some small baby steps, but after some time you will find that you have come a very long way. So all the best to all of you. And once again, thanks to the management, Vivekananda College of Engineering, plus Dr. Kannan and Dr. Kumar for hosting this and giving me this opportunity to share. Thank you.
Thank you, sir.
Yeah.
Participants, we have some guidelines. So today is the last day for online session. So we have to give assessment for online session as well as offline session, and we have to upload the marks in the portal, Atal portal. So for that, we will give you the questionnaire, which will be shared in our WhatsApp group. You please respond for the same. So based on that, we have to enter the marks in the Atal portal. And from Monday onwards, physical session starts. So from 9:30, please 9:30 to 9:45, we have planned for registration, and 10 o'clock, 10 to 10:30, we have a formal inauguration of this Atal FDP. And if you need, some people are requiring transport for utilizing our college bus, so we will provide the details of mostly the people from Karur, Salem, Namakkal, Erode. So these bus timings are given. You will be comfortable. So we will provide it tomorrow. And two members asked accommodation, and so that will be taken care. So we assure that we will provide the accommodation, but as per the guidelines, you have to bear the cost. And working lunch will be provided for all the days. And we planned Wednesday one industrial visit in the afternoon session to Sakti Automotive Limited near Perundurai. So that is also planned. And also during the offline session, teams will be participants team will be grouped. Participants will be grouped in different teams. Accordingly, journal articles will be given, so that you have to write it, and so those marks also uploaded in the portal. So these are all the guidelines I want to give you at this juncture. If you have any queries, you please put it in the WhatsApp, so we will respond for the same. Now, any questions related with today's topic to our today's speaker, Mr. Pradeep Chandrasekaran? Participants? Participants, any questions? I think. Okay, I think they are not having any questions. Okay, right, fine. Sir, I have one question, sir. Sir,
Yes,
you
sir.
said the emission electric based on this Bharat EV, sir. Is there
Yes.
any
Sir, your voice is breaking. Can you repeat the question, please?
this IC engine vehicles are satisfy the norms of BS7, Bharat Stage 7?
Uh-huh.
Any such standards for this EV, sir?
Yes, yes. We have a lot of European regulations which
Okay,
are
sir.
also mandated by certifying agency in India. Maybe I will share that link to you. It gives all the mandatory things for the electric vehicles.
Okay, sir. Thank you. Then one more question, sir. Then if you are fast charging the battery, then it will reduce the cost of the, I mean, life of the battery, no, sir? Is it
Yeah,
true?
correct, sir.
Yes, sir. Okay.
Yes, it will reduce the life of the battery, and that is the reason we shall not do the fast charging always.
Yes, sir. Okay, sir.
Hmm.
Okay, okay, sir. Thank you very much, sir.
Thank you. Thank you.
Participants, any more questions? If there is no question, we will wind up the session. Okay,
Okay.
sir. We will wind up the session, sir. Thank you very
Thank you.
much, sir.
Thank you. Thank you. Thank you all.